Before we begin, let's look into what this course contains. The course is basically organized as follows. The first section is on installing TypeScript and compiling your first TypeScript files into Javascript. It is a short but useful section in which you will learn the skills necessary to do basic TypeScript compilation. In the second section, we will explore TypeScript's beginner features. TypeScript has many features, all of which we can't cover in this tutorial series. However, we will cover some of the most important and most common. First, we'll cover types and interfaces, which are means of TypeScript controlling errors in your code. Next, we'll look into classes and inheritance, which is a way of injecting your code with powerful new functions not available in basic JavaScript. Finally, we'll look into modules and explore sharing code between TypeScript files. Have any questions, comments, concerns? If you do, I'm happy to hear them. I look forward to helping you solve any problems you may have. In order to contact me, open a discussion on the course page saying clearly what problem you may have. Some of the technologies we are using, such as NPM, TypeScript, and Node, are known to behave differently on different platforms. So don't feel like because you get an error, you did something wrong. Sometimes it just requires some special, additional troubleshooting to get it to work. In case you don't want to open a discussion, you can always send me a message via the course page. And remember, if you see an open discussion and you know how the person can solve their problem, remember to help them. You may have a unique overview that allows you to help someone even more than I could. So be sure to help and remember to be extra nice and always start with something positive if you are going to be troubleshooting someone else's code. Finally, just before we begin, just so that you know, this is a course that's appropriate for PC or Mac. We're going to be doing a lot of live coding in this course, so if you'd like to code along at home, just make sure you have Chrome and Node.js installed. We're going to look into these a bit more, as well as install a few other things, but for now, just be aware that these things are coming up. If you're on a system like Linux or Ubuntu, you may be able to do this tutorial, but PC or Mac is recommended. In this tutorial, we're going to install TypeScript on our workstation. The reason why we install TypeScript is so that we can compile .ts or TypeScript files into .js or JavaScript files. JavaScript files can be read by web browsers like Chrome or Firefox. However, TypeScript files cannot, so we need to compile them. Installing TypeScript only takes a few minutes, so let's get started. First, open up your terminal window of choice. I like to use git bash as my terminal, but you can use terminal or whatever terminal you wish. These instructions should be more or less the same on PC or Mac. I've opened terminal in a new folder, but you can open terminal wherever you want. Now to do this, you need to have Node installed. If you don't have Node installed, take a minute to install it. It doesn't take very long. With Node installed, you can install TypeScript on your computer by typing npm install-g TypeScript. npm stands for Node Package Modules, or Node Package Manager, depending on whom you ask. And it's an application that will go online, find TypeScript, and install it on our computer for us. The G flag stands for global, and that means we want to install TypeScript in the root directory, so it will be available for every application. Press the Enter key to install TypeScript. This should take a minute. After TypeScript is installed, it should be available on your computer. You can check this by typing TSC. This stands for TypeScript Compiler, and it's the tool we use to compile TypeScript. We're going to use this in a later tutorial to compile our first TypeScript application. If you ran into any errors, please let me know or troubleshoot on the website Stack Overflow. In this tutorial, we're going to create and compile our very first TypeScript app. Now you need to have TypeScript installed as well as Node in order to do this. First, let's create a new directory. I'm just going to call this directory Hello World. And let's go inside the directory, and in that directory, open the terminal window of your preference. I like to use git bash, you can use terminal, or whatever you like. Now if we type tsc, we'll verify that our TypeScript compiler is installed. Next, let's create a new file in the folder we created, and we'll call that file helloworld.ts. TS stands for TypeScript. This means it's a TypeScript file. And let's open that in the text editor of our choice. I like to use Sublime, you can use brackets or whatever you prefer. So in this file we're going to type some very simple code. TypeScript is a subset of JavaScript, which means that anything that is JavaScript is legal TypeScript. It's not the other way around, but using TypeScript we can type, for example, console log hello world. This is valid TypeScript as well as valid JavaScript. So we'll save that. Now let's go back to our terminal. And we will compile our TypeScript file. Type tsc hello world.ts. And you can see TypeScript has now created a hello world.js file. If we open this in our text editor, we can see, oh, it's the exact same as the .ts file. That wasn't very much fun. Let's try writing a bit of TypeScript instead. So now let's write a TypeScript function. We'll just have a function, we'll say function hello, and it'll take an argument, string, and it'll just console log hello plus string. Now this is still JavaScript, but we're going to add our first bit of TypeScript now. After string, add a colon followed by the word string in capital letters. This is a type annotation. This will tell TypeScript that whatever we pass into this argument is a string. Now we have some TypeScript. If we go back to our terminal, if we type node hello world.js, Node will run our hello world and output our script. If we run node hello world.ts, we'll get an error because Node doesn't understand the TypeScript. So let's type, once again, tsc hello world.ts. And it's updated our JavaScript file. As you can see, the JavaScript file looks very similar, but it will do the job. To finish it off, let's use our hello function. So instead of console log hello world, we'll call hello John. And return to our terminal, and let's run tsc once again. And we can see our JavaScript file has been updated. Now if we call node, we get the message, hello John. If we try to pass number to the argument hello, and we run TypeScript compiler, we'll get a message warning us that number is not a property of the type string. This is TypeScript at work. The compiler did not let us compile that because we have incorrectly used that. That function here expected a string, but we passed it a number. We are already starting to see the advantages TypeScript can offer to our workflow. You'll notice that at the end of the last tutorial, TypeScript threw an error. This can be a bit confusing, so let's go a bit deeper into what happens when this occurs. Now, in my JavaScript, I'm passing an integer, 1, to the function hello. Here I've used a TypeScript annotation to tell hello that this must be a string. When I try to run in the folder hello world, tsc hello world.ts, it throws an error. Let's break this error down. It shows us the file name as well as the line number and column number in which it occurs, and a description of the error. Each description can be unique, but this description says the argument of type number is not assignable to property parameter of type string. In order to troubleshoot this, the easiest way for this error is to look at the words in quotes. The word number and the word string give us a hint that we've made an error with typing our function argument. Here in the TypeScript, if I change this back to a string and I run my TSC, I no longer get an error. Errors might seem a little bit annoying in a project so small, but in a large project, they're extremely useful and can save us a long time in troubleshooting if we use TypeScript. We'll learn more about the different things in TypeScript that can cause errors later, but for now what you need to know is that you have to look in your terminal window and verify that no TypeScript errors have occurred after calling TSC. In this tutorial, we will be discussing the type system of TypeScript. Types are a critical component of TypeScript. As the name suggests, the name TypeScript is a combination of JavaScript and types. Basically, JavaScript is a language that's not unlike Java or even C#, but those languages have a thing called types. We're going to explore those and learn a little bit in a hands-on manner in this tutorial. By the way, throughout this tutorial, we'll be referring to the TypeScript handbook. You can follow along at the URL above. This is the section on basic types. These are the types that are included by default with TypeScript, and we'll be exploring a few of them. To begin, go to a new directory. Now, in that directory, create a new text document, and we're going to call it types.ts. Now open this document in the text editor of your choice, and let's open a terminal window in that directory. In TypeScript, we define a type with a colon. Let's define a TypeScript variable. We'll say var n colon number equals 1. By the way, if you're using Sublime, you can download a plugin to highlight your TypeScript. You can also download similar plugins for other text editors, including Brackets and IntelliJ. Now, if we compile this, and look at the compiled file, you'll see it's the same, but the type is removed. Why is the type removed? The reason is types are not important when the JavaScript is running, but at the step when JavaScript is being compiled from TypeScript, types allow TypeScript to detect errors. Let's have a look at how we can do that. Going back to our TypeScript file, let's take our n variable and give it a new value. We'll just give it the value Rob, which is a string. We'll save that and go back to our terminal window, and now type TypeScript types.ts. you'll get an error saying that you can't change the value of n to a string because n has been set as a number. If we go to our JavaScript file, the JavaScript has changed because this, in TypeScript's opinion, was not a critical error. So TypeScript will just warn us and assume that we'll do the appropriate thing about the warning. What could we do about this warning? We could change this statement from this to make it a number. Or we could redefine the variable n to be of the type any, which allows it to be set to anything. Now if we write in types.ts, it's okay. By the way, you generally shouldn't use the any type because it defeats the purposes of types. The stricter you are with your types, the more useful they will be in preventing you from making compiler errors. In later tutorials, we'll go into greater details in the native types that are available in TypeScript. Now you understand how the type system works. In this tutorial, we'll discuss the built-in types that are available in TypeScript. So TypeScript has the ability to add as many types as you would like using the modular class and interface system. However, it becomes built in with several useful types that you can use throughout your projects to ensure they are more reliable. For example, you can avoid numbers being accidentally coerced into strings or vice versa using these handy type operators. Let's look into them. Now, the first type that we're going to look at is a Boolean. Booleans allow you to lock a property between true or false. Let's give that a shot. So we'll open up our text editor, and here's our types.ts from the previous tutorial. So just open any TypeScript file that you'd like to work in. So we can define the variable there is winter, and we'll give it the type Boolean, and we'll make that equal to false. And now if we say is winter, and let's make that not a Boolean, let's say make it a number, 1, 2, 3. If we try to run this project, tsc types.ts, we'll get an error. That's locked. So this is going to happen with any type assignment of any kind. For the rest, we're just going to review what is available in TypeScript. You can also lock a variable to a number value. For example, we can say var count is a number, and we'll make that equal to 5. Strings can be used as a default type in TypeScript. We'll make a string, var name is a string, and we'll make that Bran. By the way, for the most part, you can use either a capital or a lowercase when you referring to the default types. Arrays are a little bit different. In TypeScript, you define an array as a vector, which is a kind of array that can only contain one type of variable. For example, in TypeScript, you can define an array that only contains strings. To do so, you would say var names, and then you would say string followed by an opening and closing square bracket, and you would define an array equal to an array of strings. We could say John, Rickon, Arya. So this is legal. If we tried to add something that wasn't a string to this array, it would not work. You would get an error. If you want to have an array with multiple types in it, change the type of array to any array type. Now, TypeScript has another property called enum. And an enum is basically an easy way to store built-in variables. So let's go with the example Starks. So we'll make an enum, Starks, And we don't use an equal sign, we'll just define it. John, Bran, Eddard, Catlin. Now we have this. So this is a set of basically strings or keys that we can refer to throughout. So now we'll define our variable and we'll say var cat is a Starks and she will be equal to Starks.Catlin. And that's how you use an enum. The last type is void, and void is the type that is not any type. It is equal to nothing. Usually you'll use it at the end of a function. In TypeScript, you define what a function returns by putting a colon after the word function, but before the curly bracket, and putting the type it returns. For example, the function getName would return a string, and that would return, for example, Bran. If I say return 1, this would throw an error. We can see that error if we try to compile our TypeScript. We're getting a couple of errors, and that's good because TypeScript will tell us what's going on. If we view the JS, we'll see that it has been updated. You'll notice that unlike our previous things, to create our enum, TypeScript has used a more advanced form of JavaScript. Generally, TypeScript does not output JavaScript that is meant to be thoroughly inspected. To conclude, the type void is used when a function does not return anything. So I can define a function returning the type void, and this function might just console.log winter is coming. So I hope that illuminated the default types in TypeScript. You will of course learn how to make all sorts of your own types to facilitate your projects, but these will surely become useful again and again. In this video, we'll be discussing interfaces. Interfaces are yet another way that TypeScript checks our code for errors as it's being compiled into JavaScript. An interface is basically a definition for an object that tells TypeScript what that object is going to be. Let's do a demonstration. So open up a TypeScript file in a folder. I'm just going to reuse our types.ts from a previous example. And make sure that file is empty. Now we're going to define a function, and we're going to say function print name, and it's going to take a Stark, which we're not going to give a type to, and we're going to say console.log stark.name. Now if we call this function and we pass it an object that has a name property, all is well and good. But if we try to pass it an object without a name property, it won't work. We'll get an error when we're running this code. Let's try to compile this TypeScript. Open up your terminal window in that folder and type tsc types.ts. What's that? TypeScript did not throw an error. We would run this code and we would get an error. In fact, let's try it. We'll say node types.js. Undefined. Well, that's not good. That could turn up to be a difficult error to find in production. How could we avoid this? In TypeScript, we can define what is called an interface to be a blueprint for the kind of object we want to accept. So we'll define an interface in our types.ts. We'll say interface Stark. And we'll give that interface a property. name, and the name has to be a string. Now in our function printName, we will define the argument that's being passed in as a Stark. So every Stark has to have a name. Now, if we call tsc types.ts in our terminal window, we'll get an error. It will say name is missing in type, and it will say that it's not assignable to parameter of type Stark. Basically, we've gotten a warning early on that this could be an error. Now we can fix this by, say, changing this value. And if we try to compile our TypeScript, the error is gone. That's very cool. That is basically how you use interfaces in TypeScript. They can save a lot of time, and they're very handy. An interface can have any number of parameters, and each one of those should have a definition of its type. So to our start interface, we can have another variable, and we'll say age, and that will be of type number. Now, if we try to compile our code, we'll get two errors. It will say that our Starks, Edward and Joe, don't have a property age. That's because in the interface, we've defined age as a required parameter. Maybe sometimes one parameter isn't required, as in this case, we want name to be required, but age can be optional. In order to define a parameter as optional, we place a question mark after the name of the variable. This tells TypeScript that this parameter is not required when using this interface. Now, if we compile our code, we don't get an error anymore. That's basically interfaces in a nutshell. Interfaces are a powerful tool for making our compiled JavaScript more reliable. In this tutorial, we will be discussing TypeScript classes. Classes in TypeScript are similar to interfaces, however they're a lot more powerful. Once again, classes basically make up the blueprint of objects. However, classes are meant to be constructed, or in other words, to have new instances of the class created. We're going to go over some of the features of classes today. Classes have many features, so I encourage you to look into classes further as homework for this assignment. To begin, let's open up a TypeScript file in our text editor. And make sure this file is empty. Now let's define a class. We'll say class Stark. And it will have a name, which is a string. And that'll be about all for now. So we can now define an object as a Stark. Type var ned equals new Stark. Now open up your terminal in the folder with your file, and let's compile that TypeScript code. So we'll say tsc types.ts. Now let's look at the compiled JavaScript code. Open up types.js in that same folder. It's created a function. It hasn't put anything in our function because so far we haven't described anything that would affect the class during runtime. However, let's try to add a property to our ned object that isn't defined by the class. So we'll say ned.saying equals winter is coming. Now if we compile this code, we get an error. Property saying does not exist on type Stark. So we know now that our definition of saying is potentially an error. This helps us prevent this from becoming an error during runtime. In order to fix this error, we could change this and remove the ned.saying. Let's add a saying property to our start class. We'll add saying is a string. Unlike members of an interface, properties in a class cannot be declared optional. However, they can implement interfaces with optional properties. We're not going to go into classes implementing interfaces in this video. Now, if we try to compile our code, we no longer get an error. Classes can also have constructor properties, which is a function when the class runs. So we can say constructor, and it can run code. Here we can say this dot saying equals Winterfell. This effectively gives it a default property. We can also give it a default property in the property definition by putting an equal sign after that. So we'll give name a default property this way. Classes can also have static properties. A static property is accessible from the class blueprint, or the object with the capital letter. So we'll define a static property for the class, and we'll say static castle is a string, and we'll make that equal to Winterfell. If we console.log stark.castle and run our code, first by running tsc, then by writing node types.js, we'll see him log his castle. Classes can also have methods, which are not the constructor. So we can say a method, and it has the following syntax. The name of the method, so we'll say hello, and just like that, in brackets. This method can have arguments, so we'll pass an argument to this one, and this will name person, and person will be a string. And we'll just console.log hello person. So we'll say ned.hello, and we'll pass it an argument, Robert, and we'll compile our code, and now we'll run it by typing node types.js. It'll say hello Robert. That's about it for classes. Classes are very powerful, and you can use them to define the behaviors of your objects in depth. In this tutorial, we'll be learning all about inheritance in TypeScript. Inheritance is a way for objects or classes to gain access to the properties of classes that are possessed by other objects. In the example in the TypeScript handbook, you can create a class snake and a class horse by extending a class animal using the keyword extends. We're going to give that a try now. Open up a .ts file in your favorite text editor and make sure it's empty. Now we're going to start by defining a class. We'll say class person, and it will have a property name, which is a string, and it will have a constructor with a name that is a string, and when it runs the constructor, it will say this dot name equals the name. Now, in the constructor of a TypeScript class, this refers to the object that will be created. And we'll give this person a function. We'll just give him the function dance. So I'll say dance, and we'll console.log this dot name is dancing. And we can now define a new person, so we'll say var Bran equals new person, and we have to pass a name to the constructor, so we'll say Bran. Now let's compile this. Open up your terminal in the folder where you created the file, and this file that I'm using is called types.ts. So I'll say tsc for TypeScript compiler, types.ts. And we get an error, and we'll just check that out there. Now let's call our new person's dance function. We'll say brand.dance, and we'll compile it. And now we'll run types.js, and it says Bran is dancing. Pretty cool, but this is just a regular object. Now we'll extend the functionality of this with a new person. So we'll say class awesome person extends person. Now the extends keyword means that this class will automatically start with all the properties of the class it extends. So in this class, we don't need to define the name or a constructor if we don't want, or dance. Now, what we want to do is override the dance function to make it a more awesome dance. So in awesome person, we'll say dance, and we'll console.log so awesome. And we'll make a new person. We'll say var rob equals new awesome person, and pass the name Rob. The reason we have to pass a name is because awesome person has the same constructor as person, and that requires a string. Then we'll say rob.dance. So let's compile this. And now if we run it, it says Brad is dancing and so awesome. But in so awesome, it doesn't say who is doing the dance that's so awesome. Shouldn't it say Rob is dancing? Well, in TypeScript, when you override a function like that, it doesn't automatically call the function in the class that it extends. This is called a super function. To call the super, you call super dot the super function you want to call. So in this case, we'll call super.dance. Now if we compile it and run it, it also says Rob is dancing. Note that it says Rob is dancing after so awesome. That's because we called super.dance after console.log so awesome. So that's about it for extending. You can use supers and such and extending to create large series of classes that are very effective. In this tutorial, we'll be discussing TypeScript modules. Modules are a powerful way to share code between files. By using modules effectively, you can keep your file size small and your dependencies clear. Let's get started. So let's say we have a useful function. Let's just write a function, and we'll call that function times2, and it will take a variable n, and it will be called a number. By the way, to code along with this at home, just create a new text document in any text editor. So the function times2 will return n times 2. Now we'll save this, and we'll just call this times2.ts. Now create a new TypeScript file, and we'll just save this one, and we'll call this util.ts. And in this one, we'll just say console.log times2 9. So this should output our function, what that said, and that should be 18. Let's give that a shot. Open up your terminal in the same directory as the two files you've created. Now type tsc util.ts. It says it can't find the name times2. That's because the only things that are available in this TypeScript file are what's written inside. For it to get access to other TypeScript files, we have to define a dependency. First, let's go back to times2.ts and make that a module. So we'll define a module, and a module is defined by module, followed by name, followed by curly braces. So we'll put our function inside that, and we'll name our module utility. Modules export classes. Once a class is exported by a module, it can be accessed by any file which requires that module. So we'll say export class, and we'll call this class useful. And inside this, we'll just define the function times2. Since this is in the class, we have to change the syntax a little bit. Just take out the word function. Now, times2 exports a module that has a class useful. Now, in util.ts, we have to define the path to the file that's required. To do so, we write // reference path equals and the name to the file. So we'll say times2.ts, and we'll close that with a closing /. Now we need to actually create the class which is imported. So we'll say var use equals new utility dot useful. Now we can call use.times2. Now if we go back and try to compile this file, we don't get any error. If we have a look at our exported file by typing node util.js, we get an error. Utility is not defined. Well, TypeScript knew what the requirement was, but since we didn't define any extra properties in TSC, TypeScript assumed we were going to compile times2.ts on its own and require it. To combine files in TypeScript, we have to use the out flag. So type tsc, and let's use the two files we want to combine, util.ts and times2.ts. Add a -- out flag, and this will be output. We'll just call this util.js. Press enter, and now it's combined those files into util.js. If we open the file util.js, we can see it's basically a combination of the two files converted from TypeScript to JavaScript. Now if we call node util.js, it outputs 18. Using modules, you can share code easily between files. In this tutorial, we'll be learning how to integrate TypeScript with Grunt. Grunt is an extremely popular and powerful JavaScript task runner. Basically, Grunt is a tool that you use in conjunction with Node to do tasks for you automatically. Tasks that are repetitive in nature, like JS hint, uglify, and of course, using the TypeScript compiler. Grunt is very popular and well supported. There are many large projects using Grunt, including Twitter, jQuery, Adobe, Modernizer, and many more. This means that you can rely on Grunt bugs being fixed quickly and new versions being released frequently. Grunt uses what is called a grunt file to manage the automated tasks that it will be performing for you. In this example grunt file, one task has been specified, uglify. The idea here is that when you call grunt from the command line, it will automatically uglify files based on the specifications you've provided. In this tutorial, we'll be taking advantage of this functionality for TypeScript. Grunt has many plugins. In many senses, that's the whole idea behind Grunt, is to have powerful plugins that automate daily tasks for you. You can take a look at all the available Grunt plugins at gruntjs.com/plugins. Here we see a massive list of all sorts of plugins that you can use in Grunt. This is a video course about TypeScript and not Grunt, so we won't go into detail about any of these plugins, though I do encourage you to take a look and see if any of them might help projects you have on the go right now move along faster and more automatically. Here at the top, we can search for a plugin. Let's search for TypeScript plugins. As you can see, there is no shortage of TypeScript plugins available. There's a plugin to compile TypeScript, a plugin to generate TypeScript documentation, and many more that do the same thing. For our project, we're interested in the TS plugin. If we click that, it will go to the NPM page for grunt-ts. Here we can see some basic information about the usage of the grunt-ts grunt plugin. In this tutorial, we will use grunt-ts to automatically compile TypeScript for us. If we have a look at grunt-ts's GitHub page, we can see that grunt-ts is fairly well supported with 133 stars. There are a fairly large amount of issues, which is a concern, but for the purpose of this tutorial, grunt-ts will suffice. As a developer, you will need to choose plugins frequently. Looking at the number of stars and the number of issues a GitHub page has is a good way to determine if a library is stable enough to use. In this case, 36 is a lot of issues, but we'll use this library anyways, since our tutorial is going to be fairly simple. To begin, open a new folder. Make sure this is an empty folder. Next, open up your terminal of choice in this folder. I like to use git bash, but you can use whatever terminal makes sense for you. Grunt works closely with npm to install packages, which are plugins that help you automate your code. Therefore, let's start this project by creating an npm package. Type npm init. And just press enter to select all the defaults. They'll all be good for this project. You can see npm has created a new package.json in our project. Now, let's install the npm modules that we'll need to complete this task. The first one we'll need is TypeScript. So type npm install TypeScript --save. This will install TypeScript and save it to our package.json. If you have a look in package.json, you can see npm has automatically added our TypeScript dependency. This will help us detect dependency conflicts if there are any. Next, we'll install Grunt and the Grunt command line interface. Type npm install grunt --save and npm install grunt-cli --save. Installing Grunt and Grunt CLI and TypeScript locally is not necessary if you have them globally installed. However, as this project uses many interlocking modules, it's good to have our dependencies managed locally. Finally, let's add a dependency and install our new Grunt plugin, grunt-ts. So let's say npm install grunt-ts-save. Now our package.json file is all set up. Next, let's set up our grunt file. Create a new file and call that file gruntfile.js. When you call the grunt command line interface tool with grunt, it will look in your current directory for a gruntfile.js. Now we'll see how to use a grunt file to tell grunt to compile TypeScript. First, type module.exports equals function grunt. Grunt will be passed in to this function when it runs. Grunt files are a little bit cryptic, so we're going to keep it simple for this tutorial. First, type grunt.load npm tasks and pass in grunt-ts. That was the package we installed using npm just a moment ago. Next, we need to define an initial configuration for grunt. So type grunt.initconfig and just pass it an empty object. Each property of this object corresponds to a task that grunt can run. Grunt is only going to run one task for us, ts. So type ts, and that will be an empty object. Now ts will be a package of different configurations. We're only going to have one kind of configuration for the ts plugin, and we're just going to call that main. As you can see, grunt involves a pattern of nested objects within nested objects. Some people like it, some people don't. If you don't, gulp is a popular alternative for many task running tasks that you would normally use grunt for. Now, many grunt tasks, including ts, take an src argument. This is going to be an array of TypeScript files that it's going to take and turn into JavaScript files. We haven't written any TypeScript yet, so we'll just leave that empty. Dest is a folder where it will send our TypeScript files after they've been turned into JavaScript files. We'll also leave that blank. Let's send those to a folder called JavaScript. Now, let's create a new folder for our TypeScript files. In your directory, create a new folder and call that TypeScript. In your new folder, create a new file and call it main.ts. Open this document in your text editor. Now we'll just add a simple statement, console.log hello world. Save that and go back to your grunt file. Now in the src, let's add this file, TypeScript/main.ts, and let's save that. Finally, you have to register a grunt task for this to run. So we'll say grunt register task, and we'll pass in default, which is a special string which will make this task run when you just call grunt, and we'll just pass in an array with one thing, ts, which is the definition for our TypeScript property. Open your terminal, and now call grunt. Grunt.ts will now compile our JavaScript. If we go back to our directory, we can see a JavaScript folder has been created, and inside a main.js file has been created. If you open that in your editor, you'll see it has output our TypeScript code. Let's dive a bit deeper. Now let's say we have multiple TypeScript files. So we'll just create a new TypeScript file and save that in your TypeScript folder and call that helper.ts. And we'll just export a simple module. We'll say module helper, and it will export a helper class. We'll call it language. and that will have a static property greeting, which will be a string, and we'll just make that greeting into bonjour and save that. Now in main.ts, we'll add a reference to that file with // and a div statement thingy. Reference path equals helper.ts. And save that, and now we'll say console.log, and instead of hello world, we'll refer to our new class. We'll say helper.language.greeting plus world. Now go back to your grunt file. Here we've only specified main.ts. We need to specify multiple files if we want grunt TypeScript to compile them all. So replace TypeScript /main.ts with TypeScript star.ts. Now run grunt. You can see grunt has now created 2 TypeScript files. If you go back to your directory and enter the JavaScript folder, you can see now we've created 2 files. What if we want to concatenate those files into one file using grunt? We can. Open up your grunt file in your text editor. Now, instead of dest, we'll add an out argument, which will take a string, and that will basically act like the out argument in the TSC command line. So we'll say javascript /main.js. Now, if you run grunt, and open your main.js, you can see now it contains both the functions. If we call node javascript /main.js, it says bonjour world. That's very cool. Overall, grunt makes a lot of sense for any TypeScript projects that you might have. Using grunt, you can find an appropriate plugin for you to automate your TypeScript tasks. Grunt, in combination with plugins like Watch, can even update your TypeScript automatically as you type it. As projects grow larger and more complex, this grows from being a luxury to being absolutely essential. Therefore, it's good for you to learn as much about grunt as you can. I encourage you to visit their website at gruntjs.com to learn about more cool ways that you can use grunt. Well, it's been quite a tutorial series. In this series, we learned how to use npm, node packaged modules, to install TypeScript on our machine. We also used TypeScript and the TSC compiler to compile TypeScript into JavaScript. On top of that, we learned a bit about types, interfaces, classes, and modules, as well as other things like inheritance and some of the interesting things about TypeScript that make it a cool tool to use. If you wish to continue your education, there are many excellent resources that I recommend. The TypeScript Handbook, which we have been referring to throughout this tutorial series, contains lots of useful information. I encourage you to read through the handbook at your leisure. It is available at www.typescriptlang.org/handbook. You can also follow the TypeScript project on GitHub. This will provide you with lots of useful information and updates about the project as it evolves. It will also assist if you wish to contribute. The TypeScript project was only recently added by Microsoft to GitHub and has already taken on a lot of momentum. You can find the repository at http://github.com/microsoft/TypeScript. You can star the repository, which lets people know that it's something you're interested in, and you can watch it by clicking the watch button and going to watching. This will alert you whenever a pull request, issue, or other update occurs on the TypeScript project. And finally, the best way to continue your education is to use TypeScript in your projects. Consider how using the powerful typing and classing that TypeScript offers can make the next project you're doing more efficient and more powerful. Well, I want to thank you very much for taking my tutorial. It takes a lot of effort and a lot of determination to sit through an entire tutorial series, and I know that you're now a little bit more able to use TypeScript in either your own projects or the workplaces. I want to congratulate you on becoming a junior TypeScript developer and in continuing to expand your education every day. Good job!